This is lesson 4, simplifying expressions using the order of operations. What is the order of operations? Or what do we mean by order of operations? What do we mean by the order of operations? Now that's what it is. What do we mean? What are operations? Addition, subtraction, exponents, parentheses, multiplication, division are true.
Multiplication, division, addition,
so that is the order of operations, but it tells us which order to do things in. Now, to simplify an expression, and this is an extremely important word. And something that I haven't done in years past that I'm definitely going to be doing this year on our test is we're going to include some definitions on tests. This would make a great fill-in-the-blank test question, right? To simplify an expression means to perform all indicated operations. Okay? Simplify an expression means if you can add, then you should add. If you can subtract, then you should subtract. If you can simplify a fraction, reduce a fraction, then you should reduce the fraction. If you can do a division, then you should do the division. You do everything that you are allowed to do, and then the problem is simplified. Okay? Now, for the most part, early on in Algebra 1, simplifying an expression means two things. Get rid of parentheses and combine like terms. Okay? If we have two things that can be added, then we add them. Get rid of parentheses. That means we either do what's inside, we perform the exponent. That's why exponents come up there pretty high, right? Do what's inside the parentheses first, then we do the exponent to get rid of the parentheses, and then we can do the rest of the stuff, combining like terms. Multiply, divide, add, and subtract. Okay? So that order of operations is all about getting things in as simplified form as possible. Now, a simplified expression has no parentheses, no like terms, and fractions are reduced, meaning that there's no common factors in the numerator or the denominator. So for now, that's what it means to simplify an expression. You get rid of all the grouping symbols, no more parentheses. Sometimes we use the distributive property to do that. Sometimes you'll just add what's inside and then get rid of the exponent to get rid of parentheses. But we've got to combine like terms, get rid of parentheses, and reduce our fractions. I really don't like that word reduced because we're really not making it smaller. We're just canceling common factors, right? It's an equivalent fraction in lowest terms. It's a better word to say. Okay? So that's the goal. When we look at an expression, we want to put it in a simplified form. When we're solving equations, the first step of the process is to simplify both sides. Is it the right width? You got it? Good? Okay. All right. Now, why is the order of operations important? Yes?
If you don't follow it, you're going to get a completely wrong answer.
Well, if we don't follow the same order of operations, you might get a different answer from someone else, right? So if when they thought about what makes sense with the order of operations and how we're going to arrive at the correct answer, this is what makes logical sense. This is how it should be done. So you sitting over here on this side of the room, Abby and Sean sitting over there on the other side of the room, you're going to get the same answer if you follow the same approach, right? Yeah, at least you are. Sean's going to miss a lot. The order of operations is important so everybody who works the same problem can arrive at the same answer. And here's an example of two different methods for working the same problem, right? What did they do first in the top method, method 1? They did the exponent first, right? And then they multiplied 2 times 9 and got 18. And then they divided by 6 and got 3. In the bottom, it looks like they did what first? They multiplied the 2 and the 3 first, right? They multiplied here first, right here. 2 times 3 is 6. Then they did the exponent, 6 squared over 6. You get 36 divided by 6 equals 6. Now, are there any arithmetic mistakes in either of these problems? No, they did all the arithmetic correct, right? 2 times 3 is indeed 6, and 6 squared is indeed 36. So this is just a one example where you can see if you do the order of operations differently, you get a drastically different answer. I mean, 6 and 3 are not the same. Okay, so that's just an illustration of why the order of operations is important. Here's another great fill-in-the-blank test question. You might write this down and put a little asterisk beside it. That asterisk will indicate to you when it's time to start studying for the next test. Mr. Hinton said this definition was important. Okay, the order of operations is a set of rules for simplifying expressions. All right. The order of operations is a set of rules for simplifying expressions. You getting these, Jay? You getting this? Okay. Order of operations is a set of rules for simplifying expressions. Okay, and what is that order of operations? Yeah, we're going to work inside grouping symbols first. Okay, parentheses, yeah, that's kind of, PEMDAS kind of helps us remember, but a better word for parentheses would be grouping symbols, right? What are some other grouping symbols? Brackets. Braces can be used as grouping symbols. They can technically, usually they're reserved for what? Braces are reserved for sets, yes? So brackets. Somebody else said it, I think. We mentioned it. A fraction bar, right? The fraction bar, it groups the denominator and numerator, you know, and it creates a group of things. A fraction bar does. A radical symbol, right? If you have a square root symbol or a cube root, anything under a radical, that's a group of things, and you got to do what's inside that group first. Okay, so the P in PEMDAS doesn't just mean parentheses; it means any kind of grouping symbol. Yes.
So if there's like a fraction bar, like there was in the last one, should we do the exponents first? Because on the last
All right. So that's an excellent question. Let's go back and have a look at that. What the fraction bar does is this, and if I were to rewrite this problem using parentheses instead of a fraction bar, here's what it would be. 2 times 3 squared divided by 6. So that's how the fraction bar works as a grouping symbol. It creates a separation. It groups everything in the numerator together. So when we do the numerator first, when we do the numerator, we're actually doing what's inside a grouping symbol. And then once you get inside the grouping symbol, you follow the order of operations. Inside the grouping symbol here, what are the two operations? We have multiplication and we have an exponent. Which one should you do first? You do the exponent. Okay? So grouping symbols in a fraction just tell you that the numerator is a group of things. It's like it's in a parentheses, and the denominator is a group of things in parentheses. So that kind of helps you. Simplify powers and roots. Now notice that it says powers and roots. I just gave you in the bell work an illustration of how an exponent can tell you to take a root. Josh asked the question, what would a number raised to the 0.8 power be? That's the 4/5. That's the 5th root of something raised to the 4th power. So exponents and square roots are the same. They fall in the same place in the order of operations. Okay. Number 3, then you multiply and divide from left to right, whichever comes first. And then number 4, you add and subtract from left to right. Add and subtract from left to right. Whichever one comes first, that's what you do first. All right? Any questions on those? And then from that, we get, parentheses, exponents, multiply and divide, addition, subtraction. The PEMDAS is what you guys are kind of used to hearing as an acrostic for the order of operations. Okay? Now, example. Everybody work this. Let's see how we do with this. This is not new, so you should be able to kind of do this correctly. Simplifying 10 times 3 plus 7 times 5 plus 4. Paying attention to details here. Okay, let's see here. Sean, what'd you get, buddy?
I'm still working it out, Mr. Henry.
Okay, he's being extra careful after that boast he made at the beginning of class. Liam, what'd you get?
I got 93.
You got
93.
93. Is 93 correct? Okay. All right, so what we would do here, guys, is first thing, following the order of operations strictly, we can do what's inside parentheses first. So we can do 30 plus 7 times 9. Okay? And then we would do which operation first? Multiply first, right? We have to multiply first. 7 times 9 is 63, and 63 plus 30 is indeed 93. Okay? So we're good on that one. Now, where are some places that you could have gone wrong in this problem if you're not careful?
On that multiplication symbol outside the adding on.
You could have add 30. You could add 30 and 7. That's kind of that's the biggest place you could do. Or you could have multiplied the 7 times the 5 and then added 4. Now, would it have been okay to do this? Yeah, because of what?
Because
The distributive property, right? The distributive property tells us it's okay to do that. If we wanted to distribute that 7 to the 5 and to the 4, we would get 30 plus 35 plus 28. 35 plus 28 is 63, so you are going to still get the same answer. And that kind of goes to how I was showing you guys to multiply two-digit numbers times two-digit numbers. You can use the distributive property at any point. All right, try this one. Now what you want to do is get to a place where the order of operations is reflex. You just do it without even really thinking about it. But at this point, you should really, really be thinking very carefully about what the order of operations is as you work an arithmetic problem like this. I'm going to turn Sean into a mathematical genius. He's going to try to go all semester without making a mistake.
If you could do that.
I'll probably forget it by tomorrow and make a mistake.
There you go. All right. Need another minute or two? Everybody done? What about it, Wadsworth? What'd you get?
I got 49.
49? Is there a consensus on 49?
I got 52.
I got 49.
So we got 39, 49, 52. All right, now so listen. So y'all listen. Shh. Listen.
Let me double check that.
Listen. Listen. So what do? Here we get 64. Right? We'll do our exponents first. Plus 9 divided by 3 minus 2 times 3 squared is 9.
Yeah.
Okay? Now, what do we do next? We have to multiply and divide first, right? So 9 divided by 3 is 3, and 2 times 9 is 18. So 67 minus 18 is 49.
I figured out what I did
Sean
wrong.
got it.
I did.
You figured out. And let's stop and talk here about what because there was three distinct answers given. Jay, what'd you do wrong?
Well, instead, I got double signs, and instead of, I got 54 plus negative 15 at the end, and I didn't.
Where'd you get 54?
Oh, I'm at 60. That's okay. Yeah, that's why I did. That's why I didn't get 49 because I did 54 instead of 64.
Oh, you just copied. You made a copy error.
Yeah.
Okay.
I just did 9.
Or you did 4. You said 4 cubed was 54.
I don't know. Yeah, I think that's might have been what I did.
Okay.
I made a silly mistake.
Made a mistake cubing the 4. Now you got to be really careful there, right? What did you do?
I just did 9 minus 3 instead of 9 divided by, like, I guess I just
Ah,
kinda, like, thought it.
You made
I really don't know.
yeah. So well, a lot of times we just make silly mistakes, right? If we're not focusing. Anybody else want to share what they did wrong? Okay. All right. Let's do another one.
Come on, Sean.
9 times 2 cubed minus 9 divided by 3.
He's still copying.
I got it down.
He's always slow anyway, isn't he?
Making sure. He just got done copying. I've been done copying down.
The answer's 64.
It's like writing it neat too.
Oh, wait in my
It's not legible.
All right. Shh. All right, guys. Focus. Liam, what'd you get, bud?
I got
69. Okay. I think that's correct. Okay. So you have to cube the 2. Shh. Quiet. Nick. You have to cube the 2. And that gives us 9 times 8 minus 9 divided by 3. Okay, that's 72 minus 3, which is 69. Now, the reason you do minus 3 is because of that. Now, guys, we didn't talk about that. We didn't talk about this in the previous problem, but we could have. Remember, anything that is subtracted, anything that is separated by plus or minus signs, we have this minus sign there. We know that's going to come last, right? So it's okay to go ahead and do this whole thing, and you could go ahead and do this whole thing because it's separated by that subtraction sign. Okay? The plus and minus signs kind of divided into groups. So here I've got a plus sign in the previous example. I should have pointed this out then. We have a plus sign there and a minus sign there. So that kind of divides the problem into 3 different problems, to 3 terms, if you will. Yeah? 3 terms, and we can do each one of those terms according to the order of operations. Right? So you don't have to strictly do all of the exponents before you multiply. You could do this exponent and the multiplication in one step because it's separated by that subtraction sign. Right? It is a term. We defined terms yesterday to be things that are separated by plus or minus signs. So we can simplify each term and then do the addition and subtraction last. Okay? Yes, Josh?
One question.
Mm-hmm.
Would that affect any answer, like with multiplying by a negative and a negative, if it had a minus sign in front and it was being multiplied by another minus, by a negative number?
It depends on how you use the negative. Yeah. If you multiply a negative, if you multiply a negative, if you use the negative when you multiply, then you need to change the negative to a positive. But if you didn't use the negative when you multiply, then you just leave it a negative.
Still have 2 negatives there.
Yes. All right. One more. Couple more. 2 times 3 minus 2 squared over 2. This one's a little easier, actually. It's just in fraction form. Okay? 2 times 3 minus 2 squared, all divided by 2. Karis, what'd you get, hon? 8. Ocho is correct. All right, so what we'll do first is everything inside this parentheses. That's 2 times 3. 6 minus 2 is 4, right? So 4 squared divided by 2, that's 16 divided by 2, which is 8. Okay? So, correct. Again, that one's a little easier than the previous ones. Now, this one they're asking us to use the order of operations on each side and compare the two values. Now, let's talk about those 3 symbols. What is this symbol right here? How do you read this symbol when you see it in a problem? Less than, right? It's always read less than. This symbol is greater than. Less than points left. So that's how you read those problems. Okay? And then, or equal. So do that. Let's have a look at these 2 evaluations and work this one. And I'm letting you guys work this because this is a review concept and you should know how to do this. If you're struggling with it, of course, we'll spend some time one-on-one fixing it. But okay. All right, just a little bit more time. Now, what I would advise you to do on a problem like this is not to work with both sides at once. Do one side, then do the other side, and then make the comparison at the end. Just think about each expression at once. Okay, what value do we get on the left? 27.5 seems to be the consensus. We'll look at that in just a second. What's on the right? 11. So 27.5 is certainly greater than 11. Okay. All right. So what we would do on the left is what's inside parentheses first. That's 4.5 divided by 9 plus 27. 4.5 divided by 9 is 0.5. 0.5 plus 27 is 27.5. Okay? 9 divided by 4.5 is 2. So you got to divide. Division has to be done in order. On the right, we have 26 divided by 2. 26 divided by 2 is 13. 13 minus 8 divided by 4. Got to be careful there. 13 minus 2 equals 11. So 27.5 and 11 are the two correct answers. Now, if I'm checking this problem on a test and you have the wrong values here, your problem's not going to be correct, even if this part is correct. That's really what I want you to know, that you can do the order of operations there and make a comparison of values. Okay? We're getting close. So this one says, a crop. Jonah is making a model of the moon using plastic foam. He uses the formula 4/3 pi r cubed to find the volume. Is that the correct formula?
Oh.
for the volume of a sphere?
Yeah.
You need to know those formulas. We're going to know those formulas. The volume of a sphere is 4/3 pi r cubed. The model moon's radius is 3/2 inches. It's 1.5, right? What is the volume of the model moon? Give the answer in terms of pi. What does that mean when it says give the answer in terms of pi? Nick?
Like 13 pi, you don't have to multiply out.
It means we're not going to be using a decimal approximation for pi, right? So all we're doing here is using a formula. Volume equals 4/3. I'm not real sure why y'all stopped writing. Pi times 3/2 cubed. So we're just putting in the radius and then evaluating. So a problem that looks really kind of foreboding with all this fancy talk and lots of words, it's really not a difficult problem. We're just substituting for a radius value. And then we're going to do our exponent first. So that'll be 4/3 pi. What's 3/2 cubed? 27/8. And now I can multiply those two fractions together. Simplify. 4 goes into 8 twice, right? 3 goes into 27 9 times. So that's 9/2 pi units. What are the units? Inches cubed. Volume is always expressed in cubic units. Okay? Any questions? All right. Homework is page 20, 1 through 30.